Find the values of a and b in the equation 2 raised to the power a minus 3 minus 2 raised to the power b minus 3 equal to 504, where a and b are positive integers. Hello, welcome to our maths class. In our class today, we are going to find the values of a and b in this exponential equation. But before we find the solutions, kindly like, comment, share and subscribe to this channel. This will enable you get our subsequent Maths Olympiad videos once they are produced daily. You get the update immediately. And as we solve this question, kindly watch this video to the end because we are going to use some maths logic and skills that you come to truly appreciate and you learn a lot from. Now let's solve this question. To solve this question, first of all, we are going to simply simplify this expression. And to simplify this expression, I want you to recall the law of indices that says if we have our value a x plus y, this will be equal to ax multiplied by ay. So if we apply this law of indices, we are going to have it that our 2a will multiply 2 raised to the power minus 3 minus 2b will multiply 2 raised to the power minus 3, and that will give us 504. Having gotten this, we can simplify this to give us 2 raised to the power a multiplied by 1 over 2 raised to the power 3 minus 2b, 2 raised to the power b multiplied by 1 over 2 raised to the power 3, and that will be equal to 504. So this will give us 2 raised to the power a multiplied by 1 over 8 minus 2 raised to the power b multiplied by 1 over 8, and that will be equal to 504. So let's multiply both sides of the equation by 8. So this will give us 2a, that will give us, let's multiply both sides of the equation by 8. So this will give us 2a multiplied by 1 over 8. This part will be multiplied by 8 minus 2 raised to the power b multiplied by 1 over 8 times 8, and then we'll have our 504 multiplied by 8. So 8 will clear 8, this 8 will clear 8, and we'll be left with 2 raised to the power a minus 2 raised to the power b equal to 504 times 8 will give us 4032. So we have arrived at the part of the equation where we need to apply the skills we acquire in mathematics. Now note that this part is definitely greater than 0. That we know. Now if we say 2a minus 2b, if 2a minus 2b gives us this value, so definitely that shows that a is greater than what? B. So if a minus b is greater than 0, that simply tells us that a and b are positive what? Integers. And this simply tells us that a is greater than what? Greater than b. So if a is greater than b, we can simply say that our a can be equal to b plus another value. Now let's assume that value to be what? Y. So we'll let our a be equal to b plus y. Now we're going to fix that into that general equation we've gotten, which is the one above. That is 2 raised to the power a minus 2 raised to the power b equal to 4032. Now let's fix that into this value. Wherever we see a, we'll replace it with b plus y. So we'll have 2 raised to the power b plus y minus 2 raised to power b equal to 32. Now, remember the law of indices. This value will give us 2 raised to power b multiplied by 2 raised to power y minus 2 raised to power b equal to 32. Now, what does this simply tells us? That there is a common value between common term here is 2 raised to power b. So we'll bring out the common term, which is 2 raised to power b. I will be left with 2 raised to power y minus 1 over here, and this will be equal to 32. Now, let's simplify 32. If we simplify 32 can simply give us 2 raised to power 6 multiplied by 63. So if we apply that here, we're going to have 2 raised to power b into bracket 2 raised to power y minus 1 equal to 2 raised to power 6 multiplied by 63. Now let's do something. We are going to do something. In these very values, we can now see that we have this value to be even, while this value is odd, this is even, and this is what is odd. So what we need to do is to equate the common similar values, to equate the common values. We equate the even to the odd and the odd to the even. So we'll have 2 raised to power b to be equal to 2 raised to power 6, and then we'll have on the other hand 2 raised to power y minus 1 to be equal to 63. So what would this give us? The half common base. So 2 will cut 2, and then we'll have our b to be equal to 6. We'll have our b to be equal to 6. We'll come over here, and then we'll have 2 raised to power y minus 1 to be equal to 63. And this will give us 2 raised to power y equal to 2. 1 comes over here to give us 63 plus 1. So that will give us 2 raised to power y equal to 64. 2 raised to power y 2 raised to power y will be equal to 64 will give us 2 raised to power 6, because 2 times 2 times 2 times 2 times 2 up to 6 will give us 64. So we've created the common base which will clear this, and then we'll have our y to be equal to 6. In this solution, we have gotten the value of b, and we've gotten the value of y. Our b we have seen is equal to 6, and we've gotten our y to be equal to 6. Now recall that we said earlier on that we allowed our a to be equal to b plus y, and we are looking for the value of a likewise. So if a is equal to b plus y, a is equal to b plus y, we'll have our a to be equal to 6 plus 6, and then our a will be equal to 12. So the two values, therefore, that satisfy that exponential equation, therefore, is a equal to 12, and then our b is equal to 6. Now, how can we be certain about this solution? Let's check our solution. Now, to check our solution, we are going to look at the initial question we are given. We are given the initial question that 2 raised to power a minus 3 minus 2 raised to power b minus 3 is equal to 504. So let's insert the value for a and b. So 2 raised to power 12 minus 3 minus 2 raised to power 6 minus 3. Will it give us 504? Let's check out that. This will give us 2 raised to power 9 minus 2 raised to power 3, and this will give us 2 raised to power 9 will give us 512. Subtract from 2 raised to power 3 will give us 8. So 512 minus 8 will be equal to 504. Voila! That tells us that this solution we've gotten for the value of a and b, which are positive integers, is the correct solution for that exponential function we've been given at the initial part of our solution. I know you did enjoy watching this video. Don't forget to give this video a thumbs up and subscribe to this channel in order to support and grow this channel. Thanks so much for watching.